In 2024, a spacecraft flying 165 kilometers above the surface of Mercury captured something that made an entire room of scientists go completely quiet. Not quiet like awe, quiet like fear. Because what they saw on that surface shouldn't be there. It can't be there. And when you understand what it means, not just for Mercury, but for every planet in this solar system, including the one you are sitting on right now, I promise you, you will not look at the night sky the same way again. We will get to that moment, the full reveal, right at the end of this video. But first, quick question before we dive in. Where in the world are you watching this right now? Drop it in the comments. I'm genuinely curious because people from 80+ countries watch this channel, and I want to know if anyone's watching from somewhere unexpected. Okay, let's go back to the beginning, because to understand what that spacecraft saw, you need to understand just how completely embarrassingly wrong we were about Mercury for over a century. For most of human history, Mercury was basically a mystery wrapped in disappointment. It's the smallest planet, the closest to the sun, brutally difficult to observe because it never strays far from the sun's glare. Ancient astronomers could barely catch it flickering near the horizon at dusk or dawn, and even then, only for a few minutes before it disappeared again. So, for a long time, the scientific consensus was basically Mercury is boring, small, dead, roasted. A cratered rock baking in radiation, not worth the difficulty of getting there. That assumption hardened into textbook fact, and it survived almost completely unchallenged for over 100 years. Here's the first crack in that story. Until 1965, scientists genuinely believed Mercury was tidally locked, meaning it always showed the same face to the sun, the way our moon always shows the same face to Earth. One side permanently in scorching daylight, the other side in permanent frozen darkness. Makes sense, right? It's so close to the sun, gravity should lock it in place. Except it doesn't. In 1965, radar signals bounced off Mercury's surface from a telescope in Puerto Rico revealed something nobody expected. Mercury is not tidally locked. It rotates, but in one of the strangest rhythms in the entire solar system. For every 2 orbits Mercury makes around the sun, it rotates 3 times on its axis, a 3-to-2 resonance, which sounds simple until you work out what it actually means. A single solar day on Mercury, sunrise to sunrise, lasts 176 Earth days. That's 2 full Mercury years packed inside a single day. Let that sit for a second. 1 day is longer than 2 years. And because Mercury's orbit is a stretched ellipse, not a clean circle, there's a window near its closest approach to the sun where the orbital speed briefly overtakes the rotation speed. If you were standing at the right spot on the equator, you would watch the sun rise, slow down, stop, reverse direction, set briefly back toward the horizon, and then rise again. A double sunrise, on the same morning. That's not a metaphor, that's just Tuesday on Mercury. But weird spin cycles and long days are just the warm-up act, because the real mystery lives underneath the surface. If you could slice Mercury in half and look inside, you'd find something that planetary scientists spent decades arguing about in increasingly frustrated academic papers. Mercury's iron core takes up roughly 85% of the planet's radius. To put that in perspective, Earth's core is about 15% of its volume. Mercury is, in the bluntest possible terms, basically an iron cannonball with a thin skin of rock stretched over it. The rocky mantle and crust together are only about 400 kilometers thick. That's thinner than the distance from Cairo to Alexandria times 2. So, how does a planet end up like this? The dominant theory for decades, a massive impact. Early in the solar system's chaotic, violent infancy, something enormous, close to the size of Earth, slammed into a young Mercury and ripped away most of its outer rock layers. What remained was the dense iron core, barely wrapped in whatever mantle survived the collision. It's a good story, clean, dramatic. And then we actually sent a spacecraft to orbit Mercury for the first time, and the story fell apart.
NASA's Messenger spacecraft arrived at Mercury in 2011. It was only the second mission ever to visit the planet. The first, Mariner 10, had done 3 quick flybys in the mid-1970s and then nothing for over 30 years. Messenger was the first spacecraft to actually orbit Mercury. It spent 4 years there, captured over 291,000 images, collected data on the surface composition, the interior, the magnetic field, the exosphere. And what it found didn't just update our models of Mercury, it invalidated them. Discovery 1. The volatiles. If a catastrophic impact had blasted away Mercury's mantle as the leading theory required, the extreme heat and energy of that event should have vaporized all of the lightweight, heat-sensitive elements on the planet. Things like potassium, sodium, sulfur, chlorine. Scientists call these volatiles. They evaporate easily at high temperatures. There should be none of them left. Messenger found them everywhere, scattered abundantly across the surface in concentrations that flatly contradicted the giant impact model. You cannot have an oversized iron core and a surface saturated with elements that high heat destroys. Not without a serious explanation for how both things are true simultaneously. Scientists scrambled. Some proposed Mercury formed much farther from the Sun in a cooler region and migrated inward over billions of years. Others suggested comets delivered fresh volatile material to the surface after the impact. A 2022 study using computer simulations proposed a glancing, hit-and-run collision, not a direct impact, that could strip the mantle more gently, preserving some volatiles while still producing the iron-dominant core we see today. Those simulations matched Mercury's mass and composition with less than 5% error.
But here's the thing no planetary scientist will deny. We still don't actually know. The honest answer is that Mercury's origin is unsolved. The closest world to our Sun, the one we've had the best chance to observe for centuries, and we genuinely cannot explain how it became what it is. That alone should give you pause. But Messenger wasn't done. Discovery 2. Mercury is shrinking right now. As Mercury's interior slowly cools, the core contracts. And when the core contracts, the surface has to fold and crack to accommodate the shrinkage. The result? Enormous cliff-like features called lobate scarps, fault lines where one section of the surface has been thrust up over another. Some stretch for over 1,000 kilometers. The largest cuts straight through a massive impact crater, meaning the scarp formed after the crater did. The planet wrinkled after it was already ancient. Scientists estimated Mercury has shrunk by about 7 kilometers in diameter over its lifetime. Picture a piece of fruit drying from the inside out. The skin wrinkles. Mercury is doing the same thing, except the wrinkles are kilometer-tall cliffs. For a long time, we assumed this was ancient history. Finished, done billions of years ago. Then, in the final 18 months of the mission, Messenger was lowered to extremely low altitudes, sometimes just 15 kilometers above the surface, and it spotted tiny, fresh-looking fractures. Cracks so sharp and pristine they couldn't possibly be old. Scientists estimated some of them could be as young as 300 million years. On geological timescales, that's not ancient, that's recent. That's practically last week. Mercury isn't a planet that shrank. It's a planet that is shrinking, present tense, active, ongoing, which means Mercury is almost certainly producing seismic events right now, quakes rippling through the crust of a world we filed under geologically dead. That classification is wrong. Discovery 3. The magnetic field that shouldn't exist. Mercury is the only rocky planet besides Earth with a global magnetic field generated by an active dynamo in its liquid core. Mars doesn't have one. Venus doesn't have one. Mercury, this tiny, ancient, supposedly dead world, does. A smaller body loses heat faster. Its core should have solidified billions of years ago. No liquid core, no churning convection, no magnetic field. And yet, Messenger confirmed that Mercury has a solid inner core surrounded by a liquid outer core. That liquid layer is driving the magnetic field. It's weak, about 1% the strength of Earth's, but it's real.
It's active, and it's lopsided. The magnetic dipole is shifted northward by nearly 20% of the planet's radius. No other planet in the solar system has an offset like that. The result: Mercury's southern hemisphere is far more exposed to the solar wind than the north. Charged particles from the sun slam into the south with greater intensity, physically altering the surface composition over billions of years. The north and south of Mercury may now be chemically different because of a magnetic asymmetry we still cannot explain. But none of these discoveries, not the volatiles, not the shrinking, not the magnetic anomaly, prepared scientists for what they found next.
The hollows. There is nothing else like them anywhere in the solar system. Thousands of shallow, flat-bottomed, rimless depressions scattered across Mercury's surface, clustered inside impact craters and glowing, visibly, strikingly brighter than almost anything else on the planet. When Mariner 10 flew past in the 1970s, it caught faint hints of unusual bright patches. No one knew what they were. Messenger revealed them in full, and the first thing scientists noticed? No impact craters inside the hollows. In planetary science, that's a timestamp. If a surface feature has no craters overlaid on it, nothing has had time to hit it since it formed. It's geologically young, possibly very young. Some of these hollows may be less than tens of millions of years old. Some may be forming right now. The leading theory? The hollows are created by sublimation. Volatile compounds trapped inside the rock, sulfides, graphite, other heat-sensitive minerals, are being exposed to Mercury's brutal solar radiation and the constant bombardment of charged particles from the solar wind. Without an atmosphere to offer any protection, these materials don't just heat up. They vaporize directly out of the solid rock. The structure that held them collapses. A depression forms. A hollow. Mercury's surface is, in the most literal sense, evaporating, and it's been doing this recently, actively, continuously. Which brings us back to that room of scientists in 2024. Bepi Colombo, the joint European and Japanese mission that launched in 2018, completed its fourth flyby of Mercury in September 2024, passing just 165 kilometers above the surface. The images it captured were the most detailed ever taken of some of Mercury's largest impact basins. But it was the fifth flyby, in December 2024, that stopped the room. For the first time in history, a spacecraft observed Mercury in mid-infrared light, a wavelength that reveals temperature and composition variations invisible to every previous instrument ever sent there. What they saw were patterns of volatile enrichment and surface activity that did not match any of our existing models. Not slightly off, not within an acceptable margin of error, fundamentally inconsistent with what we expected. The surface chemistry, the temperature variations, the distribution of bright regions, all of it pointed to a planet that is far more chemically active, far less depleted, and far more geologically alive than any model predicted. Researchers who had spent careers studying Mercury described that first look at the data with one word: breathtaking, and not in the good way, in the "we may need to rethink this from the beginning" way. Bepi Colombo enters orbit in late 2026. When it does, two separate orbiters will spend at least a year probing Mercury's surface, interior, magnetic field, and exosphere with instruments 10 times more capable than Messenger's. They will look for hollows that have changed since Messenger last mapped them. They will look for new ones. And somewhere at Mercury's poles, in craters so deep the sun has never touched their floors, not once in 4.5 billion years, there is water ice on the closest planet to the sun. Ice that has survived longer than complex life has existed on Earth, hiding in permanent darkness while the surface above it bakes at temperatures that melt lead. That's Mercury. Not a dead rock, not a footnote, not a leftover,
A world that is cracking apart, evaporating from the inside, magnetically lopsided, chemically contradictory, hiding ice in eternal shadow, and actively, right now, doing things we cannot explain. We sent more spacecraft to Mars in 1 decade than we have sent to Mercury in all of human history. We dismissed it because we assumed we already understood it. We didn't. The more we look, the more unsettled the picture gets, and Bepi Colombo hasn't even begun its main mission yet. Whatever it finds when it finally settles into orbit around Mercury in 2026, we should probably be ready to be wrong again. If this video made you rethink something, share it with one person who would find it fascinating, and subscribe, because the next video in this series covers something on Venus that is even harder to explain. I'll see you there.